In question 1, the term independent of x in the expansion is 540. So we know that the independent term means that the power of x is 0. So either we can guess which term will give us the independent term, or we can use this expansion formula, which is 6CR a to the power n minus r, and this is k x to the power minus 1 to the power r, x to the power 0. So we can just compare the powers of x to get what is the value of r that will give us the constant term. So this will become x6 to the power minus 6 minus r multiplied by x to the power minus r is equals to x to the power 0. Comparing the powers, we have 6 minus r is equals to 0. 2r is equals to 6. So r is equals to 3. So we know that 6c3 will give us a term which will basically cancel out the value, the x. So 6c3 a to the power 2x, a is 2x, so 2x to the power 3 into k upon x to the power 3 is equals to 540. 6c3 is 20 times 8x cube into k cube upon x cube is equals to 540. So we have k cube is equals to 540 divided by 160, which is 3.375. Taking the cube root of 3.375, we get k is equals to 1.5. In part 2, for this value of k, we have to find the coefficient of x squared. So we know that the term was 2x plus k upon x, and the value of k is 1.5 or 3 upon 2. So this can be written as 2x plus 3 upon 2 x to the power 6. For the coefficient of x squared, again we can use 6cr, 2x to the power 6 minus r, 3 upon 2 x power minus 1 to the power r is equals to x squared. Comparing the powers, we'll have 6 minus r is equals to 2. So 2r is equals to 4 and r is equals to 2. Now to find the coefficient, we can just use the formula 6c2, a to the power 6 minus 2, which is 4, and 3 upon 2x to the power r, which is 2. 6c2 is 15, 2 to the power 4 is 16, x to the power 4 multiplied by 9 upon 4x squared. So we can see that x power 4 and x squared will cancel to give us x squared. 15 times 16 times 9 will be 540 x squared. So the coefficient of x squared is 540. In question 2, we have a line which is a tangent to the curve at the point P. We have to find the value of C. So as it is a tangent, it means there is only one point of intersection. So from the equation of the line, we know that y is equals to x plus c upon 4. Equating the two equations, we'll get, so in place of y, we can substitute x plus c upon 4 whole squared is equals to x plus 3. Now, as it is only one point of intersection and there's an unknown constant, so we'll be using b squared minus 4ac, and it will be equals to 0 as there's only one point of intersection as it is a tangent. So expanding this, we'll get x squared plus 2xc plus c squared upon 16 is equals to x plus 3. Cross multiplying, we'll get x squared plus 2xc, so this is a 2xc, plus c squared is equals to 16x plus 48. Simplifying this, we get x squared plus 2xc minus 16x plus c squared minus 48 equals to 0. So the value of a is 1, as the coefficient of x squared is 1. The value of b, which is the coefficient of x, will be 2c minus 16. As if we take x common over here, we'll get 2c minus 16. So the value of b is 2c minus 16, and the value of c is c squared minus 48. Now using the discriminant b squared minus 4ac, we'll get So b is 2c minus 16. So 2c minus 16 whole squared minus 4 into 1 into c squared minus 48 equals to 0. Expanding this, we get 4c squared minus 2ab, which will become minus 64c plus 256 minus 4c squared plus 4 times 48 is 192 equals to 0. 4c squared and 4c squared cancels out. So we have 64c is equals to 256 plus 192, which is 448. So c is equals to 448 upon 64, which is c equals to 7. In part 2, we have to find the coordinates of P. To find the coordinates of P, we'll use the simplified form as we had already equated the two equations. So we have x squared plus 2xc. So we write 2x and in place of c we can write 7 minus 16x plus 49. C squared is 49 minus 48, which will become 1. So our equation will be x squared plus 14x minus 16x will give us a minus 2x. So we have x squared minus 2x plus 1 equals to 0. Factorizing this, we'll get x minus 1 and x minus 1 equals to 0. So the x coordinate is 1. To find the y coordinate, we can just substitute x equals to 1 in any of the two equations. So we have y squared is equals to x plus 3. So y squared is equals to 1 plus 3, which is 4, which will give us y equals to 2. So the coordinates of P are 1, 2. Question 3. A sector of a circle of radius r has an area of A. Express the perimeter in terms of r and A. So we know that a sector basically has an angle, let's say theta, the radius is r. So the perimeter of the sector consists of two radiuses and the arc length, which is s is equals to r theta. The area is A is given by half r squared theta. So we can write theta is equals to 2a upon r squared. As our perimeter has to be given in terms of r and a only, which means we have to substitute something in place of theta. So first we can write perimeter is equals to 2r plus r theta. And in place of theta, we can write 2r plus r times 2a upon r squared. Cancelling r and r squared, we get the perimeter as 2r plus 2a upon r. In question 4, we have a trapezium with the coordinates A, B, and C. The lines BC and AD are parallel and CD is parallel to the x-axis. We have to find the value of H. Now to find the value of H, we can see that as AB and BC are perpendicular, the gradient of AB multiplied by the gradient of BC will be is equals to minus 1. So the gradient of AB can be written as y2 minus y1, so 0 minus 2 upon x2 minus x1 multiplied by the gradient of BC, which will be 3h minus 2 y2 minus y1 upon h minus 0 is equals to minus 1. So this will become minus half multiplied by 3h minus 2 upon h is equals to minus 1. The negative sign will cancel out. So we can write 3h minus 2 and the 2h can multiply by 1, which will make it a 2h. So 3h minus 2h is equals to 2. So h is equals to 2. In part 2, we have to find the coordinates of D. Now, as C and D are parallel to the x-axis, we can safely assume that the y-coordinate of C and H will be same. So, the coordinates of D can be written as x, 3h. So, as a value of H is 2, so D is x, 6. Now, if we can form an equation of the line AD or CD, we can substitute y equals to 6 to find the value of x. Now, to find the equation of AD, we know that the gradient of BC and AD will be equal. So as the gradient of AB is minus 1 upon 2, the gradient of BC is equals to 2, which is the same as the gradient for AD. So the equation of AD will be y minus y1. So the y coordinate of A is 0. So y minus 0 is equals to 2 into x minus 4. So the equation of AD is y is equals to 2x minus 8. And as we know that the coordinates of D are x comma 6, substituting 6 into the equation, we get 6 is equals to 2x minus 8. So 2x is equals to 14, and the x coordinate will be 7. So the coordinates of D are 7 comma 6. In question 5, we have a function f of x minus 2x squared plus 12x minus 3. We have to express this in the form minus 2x plus a whole squared plus b. So to convert into the form, first we'll expand the given expression, which will become x squared plus 2ax plus a squared plus b. Expanding this, we get minus 2x squared minus 4ax minus 2a squared plus b. Now to find the values of a and b, we'll compare it with the equation, the original equation, which is minus 2x squared plus 12x minus 3. So the coefficient of x on the left hand side is minus 4a, and the coefficient of x on the right hand side is 12. So minus 4a is equals to 12, and a is equals to minus 3. The constant term on the left hand side is minus 2a squared plus b, and on the right hand side it is minus 3. So minus 2 into minus 3 whole squared plus b is equals to minus 3. B is equals to minus 3. So this will be positive 9 times 2 minus 18. So this will be minus 3 plus 18. B is equals to positive 15. So this will be written as minus 2 into x minus 3 whole squared plus 15. In part 2, we have to state the greatest value of f of x. Now we know that this is the full squared form, and 3 and 15 are the coordinates of the turning point. As it is a maximum point, we can say that the greatest value of f of x is 15. So the greatest value of f of x is 15, or f of x is less than or equals to 15. In part 3, it says that the function g is defined by 2x plus 1, and we have to find g f of x plus 1 is equals to 0. So we know that f of x is equals to minus 2x squared plus 12x minus 3, and this it can also be written as minus 2 into x minus 3 whole squared plus 15. G of x is equals to 2x plus 5. So for g f of x, in the function g of x, in place of x, we can write the whole function f of x. So we can write it as 2 into minus 2x squared plus 12x minus 13 plus 5. So this is a plus minus 3 over here. Expanding this, we get minus 4x squared plus 24x minus 6 plus 5 equals to 0. Simplifying this, we get minus 4x squared plus 24x minus 1. So this is the function g f of x. Now we have to find the value g f of x plus 1 equals to 0. So g of f x is minus 4x squared plus 24x minus 1 plus 1 equals to 0. 1 and 1 will cancel, so we will have minus 4x squared plus 24x. Now, a very common mistake that students make is they write minus 4x squared is equals to minus 24x. They cancel the negative sign and they cancel the values of x squared and x to give x equals to 6. However, they lose out on one of the solutions. So it is always better to first take common. So we have minus 4x squared plus 24x equals to 0. Taking 4x common, we'll get minus x plus 6 equals to 0. So our two solutions will be x is equals to, so minus x plus 6 equals to 0, which will give us x equals to 6, and 4x equals to 0, which will give us x equals to 0. So these are the two values of x for which g of fx plus 1 is equals to 0. In questions, if we have to prove the identity 1 upon cos minus tan x whole squared is 1 minus sin x upon 1 plus sin x. So we can start by writing tan as sine upon cos whole squared. Taking the LCM, we have 1 minus sine whole squared upon cos squared. So we also know that cos squared can also be written as 1 minus sine squared. If we factorize the denominator, we'll get 1 minus sine whole squared upon 1 minus sine 1 plus sine. The numerator can be written as 1 minus sine into 1 minus sine upon 1 minus sine 1 plus sine. Cancelling this, we get the identity which is 1 minus sine x upon 1 plus sine x. In part 2, we have to solve the equation 1 upon cos 2x minus tan 2x. So we have proven that this is equals to 1 minus sine upon 1 plus sine. We can change it as 1 minus sine 2x upon 1 plus sine 2x is equals to 1 upon 3. Cross multiplying, we'll get 3 minus 3 sine 2x is equals to 1 plus sine 2x. Simplifying this, we get 2 is equals to 4 sine 2x, or sine 2x is equals to half. Now our range is from 0 till pi. So first we'll find the basic angle. Shift sine inverse of half will become pi upon 6. Now we know that sine is positive in the first and the second quadrant. So we'll write pi upon 6 over here and pi upon 6 over here. So 2x is equals to the first angle is pi upon 6 and the second angle will be pi minus pi upon 6. So 2x is equals to pi upon 6 and pi minus pi upon 6. So x will be is equals to pi upon 12 and pi minus pi upon 6 divided by 2 will become 5 pi upon 12. In question for the third and fourth terms of a geometric progression 48 and 32, we have to find the sum to infinity. Now we know that the common ratio is two consecutive terms that are divided by each other. So we have the fourth term and we have the third term. If we divide them, we'll get the common ratio. The common ratio will be 48 upon 32, which will simplify down. So this is 32 and 48. 32 and 48. So this will become 2 upon 3. We have to find the sum to infinity of the progression. Now, the sum to infinity is given by a upon 1 minus r. We need to find the value of a first. So we know that the third term is 48. So the nth term of a geometric progression is given by a r n minus 1. So this is 48. A is unknown and r is 2 upon 3 to the power 3 minus 1, which is whole squared. So this will become 48 is equals to 4a upon 9. A is equals to 48 into 9 upon 4. So 4 ones are 4 twelves are A is equals to 108. So the sum to infinity will be 108, 108 upon 1 minus 2 upon 3. Substituting this in the calculator, we get the sum to infinity as 324. In part B, there are two schemes for increasing the amount of household waste that is recycled each week. Scheme A is to increase the amount of waste recycled each month by 0.16 tons. Now we know if the increase is constant, it is an arithmetic progression where the common difference is 0.16. The total time or the value of n in this case is 24. And in the first month, which means the value of A is 2.5. In part A, we have to find the total amount that would be recycled over a 24th month period for scheme A. So we know that the sum for an arithmetic progression is given by n upon 2, 2a plus n minus 1 into d. This will become 24 upon 2 bracket 2 times a, which is 2.5, plus 24 minus 1, which is 23 into 0.16. So this is the sum of 24 terms. Substituting this in the calculator, we get 12 into 5 plus 23.16 is 3.68, which will give us the sum of 24 terms as 104.16 tons. As we have to give our answer in three significant figures, so the final answer will be 104 tons. For scheme B, the amount of waste recycled is increasing by 6%. So we know that this is a geometric progression, and the common ratio will be 106 as it is increasing by 6% from the original value, which gives us our common ratio as 1.06. The sum for 24 terms would be, the formula is A into Rn minus 1 upon R minus 1 when R is greater than 1. The value of A is 2.5 and the common ratio is 1.06 to the power 24 minus 1 upon 1.06 minus 1. Substituting this in the calculator, we get sum of 24 terms as 127 tons. Question 9, we have a function f which is 2 minus 3 cos x. In part 1, we have to state the range of f. Now, in a trigonometric function, f of x is equals to a plus b cos of x, the maximum value is given by a plus b and the minimum value is given by a minus b. So a is equals to 2 and b is equals to 3. We'll not take the minus 3 as it is the amplitude, so it will be 3 units above. So this will be 2 plus 3, which is 5. And the minimum value would be 2 minus 3, which is minus 1. So f of x is greater than equals to minus 1 and less than equals to 5. Part 2, we have to sketch the graph of y is equals to f of x. So we already know that the minimum value is minus 1 and the maximum value is 5. As it is a minus cos graph, minus 3 cos x, so it will be an inverted cos graph. So let's say this is pi and this is 2 pi. So the graph will reach its maximum point at pi and will be like an inverted cos graph. In part 3, the function g is 2 minus 3 cos of x. We have to state the largest value of p for which g has an inverse. So for any function to be inverse, it must be a 1-to-1 function, which means there must be only one value of x for any value of y. So we can see that up till this point, this function is a 1-to-1. So the largest value of p would be pi for which the function will have an inverse. So p would be equals to pi. In part 4, for this value of p, we have to find an expression for g inverse. So we know that g of x is equals to 2 minus 3 cos x. To find an inverse, first we write y in place of the function g of x. Then we exchange the values of x and y. So this will become x is equals to 2 minus 3 cos y. So 3 cos y is equals to 2 minus x. Cos y is equals to 2 minus x upon 3. So y is equals to cos inverse of 2 minus x upon 3. So the inverse function g of x is cos inverse of 2 minus x upon 3. In question 10, a curve for which the double derivative is 2x minus 5 has a stationary point at 3, 6. We have to find the equation of the curve. Now the stationary point means that the dy dx will be 0. So integrating the double derivative, we'll get dy dx. So dy dx is equals to 2x square upon 2 minus 5x plus c. Now the stationary point is at 3, 6. So we can write dy dx is 0 when x is equals to 3. This will give us the value of c. So 2 and 2 will cancel out. C will be is equals to 3 squared is 9. 9 minus 15 is minus 6. So C will be is equals to 6. Now integrating dy dx will give us the equation of the curve in terms of y. So we know that dy dx is equals to x squared minus 5x plus 6. Integrating this, we get y is equals to x cubed upon 3 minus 5x squared upon 2 plus 6x plus we'll add the constant k. Now to find the value of the constant, we have the coordinates 3, 6 that are on the curve. So substituting 6 in place of y and 3 in place of x, we'll be able to find the value of k. Simplifying this, we'll get k is equals to 6 minus 27 upon 3 is 9 plus, so this will go on that side. So this is 45 upon 2. 9, 3 squared is 9. 9, 5 is 45 upon 2 minus 18. So k is equals to 1.5 or 1 whole 1 upon 2. The final equation can be written as y is equals to x cubed upon 3 minus 5x squared upon 2 plus 6x plus 3 upon 2. In part 2, it is saying to find the x coordinate of the other stationary point. So we know that dy dx is equals to x squared minus 5x plus 6. For the stationary point, we put it equals to 0. Factorizing this, we'll get x minus 3 and x minus 2 equals to 0. As already x equals to 3 was given, so it means the other coordinate will be x is equals to 2. To determine the nature, we will use a double derivative. So the double derivative is 2x minus 5. So we know that d square y upon dx square is equals to 2x minus 5. Substituting 2 into the equation, we get 2 into 2 minus 5, which is minus 1. Now, as it is less than 0, we'll say that d square y upon dx square, as it is less than 0, it is a maximum point. So when x equals to 2, it is a maximum point. Substituting 3 into the equation, we'll get 2 into 3 minus 5, which will give us a positive 1. So now in this case, the double derivative is greater than 0, which means x equals to 3 will give us a minimum point. In question 11, the diagram shows a part of the curve and a point P that lies on the curve. The normal to the curve intersects the x-axis at Q. So in the first part, we have to find the x-coordinate of Q as 16 upon 9. To find the x-coordinate of Q, we need the equation of the normal. To find the equation of the normal, we already have the point. To find the gradient, we'll find the gradient of the tangent and then take the negative reciprocal. So y is equals to 3 into 1 plus 4x to the power minus 1 upon 2. Differentiating this, we get dy dx is equals to minus, so minus 1 upon 2 will multiply by 3 and become minus 3 upon 2 into 1 plus 4x. Decreasing the power by 1, we get minus 3 upon 2 into 4. So the dy dx is minus 6 upon 1 plus 4x to the power 3 upon 2. P is a point which on the normal, so it means we can use x equals to 2. Substituting x equals to 2, we get minus 6 upon 1 plus 4 times 2, 8. So 1 plus 8 is 9, 9 to the power 3 upon 2. So 9 to the power 3 upon 2 is 27, which gives us the gradient of the tangent as 2 upon 9. So this is the gradient of the tangent. The gradient of the normal would be positive 9 upon 2. Forming the equation of the normal, we'll get y minus the point P is 2 comma 1. So y minus 1 is equals to 9 upon 2 into x minus 2. For the coordinates of Q, we know that it is lying on the x-axis, which means the coordinates will be x comma 0. Substituting 0 in place of y, we'll get minus 1 is equals to 9 upon 2 into x minus 2. So this will become minus 2 is equals to 9x minus 18. So minus 2 plus 18 will be 16. So x is equals to 16 upon 9. In part 2, we have to find the area of the shaded region. Now the area of the shaded region will basically be, if we find the total area under the curve and subtract the area of this particular triangle, we will be able to find the shaded region. So the shaded region, area of the shaded region will be given by area under the curve minus the area of the triangle. So the area under the curve will be given by first integrating the equation of the curve. So the equation of the curve is 3 into 1 plus 4x to the power minus 1 upon 2. The limits are 2 and 0. Integrating this, we get 3 into 1 plus 4x to the power positive 1 upon 2. As we add 1 when we integrate, we divide by the new power, which is half, and multiplied by the derivative of the function, which is 4. So we get 3 upon 2 into 1 plus 4x to the power 1 upon 2. Substituting the limits 2 and 0, we get 3 upon 2 into 1 plus 4 times 2, 8. So this will be 9 to the power 1 upon 2 minus 3 upon 2 into 1 plus 0 to the power 1 upon 2. The area under the total area under the curve will be 9 upon 2 minus 3 upon 2, which is equals to 6 upon 2, which is 3. Now the area of the triangle would be, so we know that the height of the triangle is 1 and the base, we know that the coordinate of P is 2 and the x coordinate of Q is 16 upon 9. So the base will be 2 minus 16 upon 9. So the area of the triangle would be half into base, which is 2 minus 16 upon 9 multiplied by 1, which becomes 1 upon 2 into 18 minus 16 upon 9, which is 2 upon 9. So the area of the triangle is 1 upon 9. Subtracting the area under the curve from the area of the triangle, 3 minus 1 upon 9 will be is equals to 28. 9 6 are 27 minus 1 will become 26 upon 9.